Welcome to the second half of Module 2, Part 2. In the first half of Part 2, we have seen the two feedback topologies, that is, voltage amplifier and current amplifier. Next, we will see the series CDs feedback topology. It is also called as the transconductance amplifier. Here in this series feedback, the input side is a series connection, and similarly the output side is also a series connection. As we have seen in voltage amplifier, the series connection increases the input resistance. Similarly, in this case, the input resistance and the output resistance is high. This is the example of the transconductance amplifier. Here in this circuit, it utilizes the differential amplifier A1 and a CS stage Q2. This is a common source stage Q2. The output current I0 is fed to the load resistance and the feedback resistance RF, which is connected in series with the load RL. The voltage Vf across feedback resistance Rf is fed to the positive terminal of the differential amplifier. So this feedback resistance Vf is subtracted from the source resistance Vs to get the input voltage Vi. This voltage is fed to the differential amplifier. The polarity of Vf and Vs should be same. Any change in the source resistance Vs will result in the negative change at the gate terminal of the Q2. So this change in turn increases the output current I0. This increase in output current I0 will result in the positive change in Vf, which is assumed to be of the same polarity as that of Vs. So here we can see the input voltage change in input voltage will result in the change in the output current. So for this transconductance amplifier, the input signal is voltage and the output signal is the current. Next, we'll see the shunt feedback topology. It is also called as the trans resistance amplifier. This topology is because of the shunt connection at the input side and similar shunt connection at the output side. As we have seen in the current amplifiers, the shunt connection results in a decrease in the input resistance. So here in this topology, the input resistance over here and the output resistance over here is low. The shunt connection at the output side stabilizes the output voltage V0 and causes the output resistance to reduce. So Ri and R0 are low in this trans resistance amplifier. This is the diagram or example of the trans resistance amplifier. Here the circuit uses an op-amp and the feedback resistance RF. The feedback resistance RF senses the output voltage V0 and provides a feedback current IF to the inverting input terminal of the op-amp. IF is subtracted from the source current IS. So IS minus IF will result in to the input current II. If the source current Is increases, the input current II will also increase, causing the voltage at the negative input terminal to rise. Across this, the input voltage will rise. As a result of this, the output voltage will decrease, causing an increase in IF. IF and IS have the same polarity. So this is about the four type of topologies. The series shunt feedback topology, which is also called as an voltage amplifier. The shunt series feedback topology, which is called as an current amplifier. Next is the transconductance amplifier, which is the series feedback topology. And the fourth one is trans resistance amplifier, which is the shunt series feedback topology. Thank you.